Hello, this is Mrs. Butcher. This video is about inverses of quadratic and cubic functions. Now this is a review because we learned about inverse functions way back in Module 1. In fact, there's a video, it's Module 1, Section 4. If you want to go back and rewatch that to refresh your memory on inverses, you can. But some quick review, to find the inverse of a relation or a function, all you have to do is switch your x and y. And then if it's a function and you want to find the inverse function, you then solve for the new y. And then remember to verify if two functions are actually inverses of each other. If you plug g into f, and if you plug f into g, they will both equal x when you simplify them. So in this video, we're going to focus on the inverses of quadratics and cubics. And it's important to note that the inverse of quadratic functions are going to be square root functions. You know that because if you undo a square, you take a square root. And the inverses of cubic functions will be cube root functions. All right, here's an example. I want you to find the inverse of f of x equals 1/27 x cubed plus 2, and then graph both. So we're going to switch x and y. Remember, f of x is the same thing as y. So I'm going to say x equals 1/27 y cubed plus 2. And then I'm going to solve for y. So I'm going to subtract the 2 first. And then I'm going to multiply by 27. And then I'm going to take the cubed root. And I didn't distribute the 27 because I knew I was going to be taking the cube root of it, and I know the cube root of 27, so I just went ahead and left it separate so that I could say that this is y equals, and then the cubed root of 27 is 3, and then I still have the cubed root of x minus 2. And since this is a function, I'm going to go ahead and write f to the negative 1 power of x, because it's an inverse function, equals 3 cube roots of x minus 2. There we go. If it wasn't a function, you would just keep it y, or you can make it g of x, or whatever else you want. So now if we're going to graph both, it's going to look like this. That's just the first one, 1/27 x cubed plus 2. It's a cubic function, so remember it's odd, so it's and it's positive, so it's up on the right and down on the left, plus 2, so it's shifted up 2. Now if we graph the cube root function, it'll look like this one. So there's the cube root function. And if we put them both in the same screen, here's what it's going to look like. And if you remember from when we learned about inverses the first time, remember inverses are supposed to be reflected over the line y equals x. Well, there's the line y equals x. It's a little stretched out on here because it's a rectangular window, but there it is. They're reflections of each other. Okay, now I want us to look at the original function f of x equals x squared. We know what that looks like. I'm just going to sketch it. That didn't do what I wanted it to. Sorry, I'm just going to sketch it. We all know it's a parabola, right? With the vertex at the origin. That's a function. However, when we find the inverse, if we switch x and y, x equals y squared, y equals plus or minus the square root of x. So positive square root of x looks like this, and negative square root of x looks like this, and we have the inverse. It's reflected over the line y equals x, right? Like right there. I know my sketches are kind of bad, sorry. However, that's not a function, is it? It fails the vertical line test. Each of our inputs have 2 outputs. So in order to make this inverse be a function, we're going to restrict the domain. And I mean the domain of the original function, because if I limit just that side of the original function, then my inverse will just be that side, just the top part, and it will be a function too. So we're going to restrict our domain like this. We'll say, okay, the original function f of x equals x squared, but only the x's that are greater than or equal to 0. So only the right half of that parabola. So that when we find the inverse, and we say x equals y squared, y equals, we're not going to do plus or minus anymore, because we're only doing the positive x's. So we're only doing the positive square root. And so now here's your inverse function, and they're both functions. So here's another one. Say I wanted the inverse of 3x squared with a restriction of x is greater than or equal to 0. That means that x equals 3y squared. First we have to divide by 3, and then we can take the square root. And because we are restricted, think about this. Think about it this way. This said x is greater than or equal to 0. Well, when I switch to x and y, just switch there too. So now y has to be greater than or equal to 0. Y has to be positive. So therefore, I'm not going to do plus or minus. Y has to be positive. I'm only going to do plus. Y equals the positive square root of 1/3 x. And when we graph that, once again, the 3x squared is x squared stretched by 3, right? And the square root of 1/3 x, only the positive part would be this right here. All right, I want to do one more of these for you guys because this time I want to give you the original function as the root, and then we're going to find the inverse of it. Please note that I did not put plus or minus in front of it. If the author of the question wrote the square root, you take whatever sign is in front of it, and when there's nothing in front of it, it's implied to be positive. So we are only taking the positive square root of x minus 2. So to find the inverse, we'll say x equals the square root of y minus 2. The first thing we need to do is get rid of the square root, so we're going to square both sides of the equation. X squared equals y minus 2. And then to get y by itself, we can add 2. But we have to include our restrictions, because the restriction on this, y had to be greater than 0, right? Greater than or equal to 0. So when we switched, x has to be greater than or equal to 0. So when we write our final inverse, we have to include the fact that x has to be greater than or equal to 0. So it's really only half of the parabola. And so if we graphed it, the square root of x minus 2, the minus 2 inside shifts it right 2, like that, whereas x squared plus 2 shifts it up 2. And we're only graphing the positive part, so only this part. So there's our inverses. And then one thing I wanted to tell you that's really cool, actually I'm going to switch the page, is if you want to graph a restriction in your calculator, when you go into y equals, you can type your function, blah, 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 blah. Then you're going to type a slash, a divided by, you hit the divided by, and then in parentheses, x is greater than or less than or whatever, the symbols are all in second math, and then 0, like that. And it'll actually only graph the part that you tell it to. And you guys are all at the door waiting on me, so I'm going to go now. Have a good night.